Okay, we will start the session. In the last class, we were discussing about how each the port pin P0.0 to P0.31 of the port 0, P1.16 to P1.31 of the port 1 can be used for multiple functions to accommodate the different logics or the peripherals present inside the microcontroller. So three registers are there, pin selection 0, 1, and 2, which are used to define the function, the four functions, one of the four functions of each of the port pins. So I have shown that whenever you are using the pin selection register to select a particular pin and define the function of your requirement, you have to keep in mind you should not disturb other bits of the pin selection register because they are used to define functionalities of different other pins. You should not disturb them. You should only modify the bits corresponding to the port pin which you are interested. For that, I said you have to first, since 2 bits are there for every port pin, first make them 0 because we do not know what is the earlier value. So make them 0. So for that, I told you that. So we will be using this instruction, so which clears the required 2 bits of a pin of your choice. So then, so choose the function what you want to do it. If the first function means 0, you want to set for the first alternate function means 1, second alternate function means 2, third alternate function means 4. Sorry, the 3. So 0, 1, 2, 3. So the 0th function, the first alternate function, second alternate function, third alternate function. That you can define here by writing 0, 1, 2, 3. So then you are that with the pin selection registers, so that only those 2 bits become set to the required function. So I also shown by running that program in a simulator how that the pin functionality will change when you execute these 2 instructions. I will do one more. So, and we will continue with GPU pin handling or GPU port handling today in the class. So let's say I want to set so P0.18. So I want to set P0.18. Whenever you want to set P0.18, always what is the first step required? Identify which is a pin selection register which is available for this pin. We know that pin selection 0 is meant for, so 0.0 to 0.15, 0.16 to 0.31 is managed by pin selection 1. So choose that register, pin selection 1. The one difference you can always find out is the pin selection 1 and the 2 registers are there to set the pins. The numbers start from 16 onwards, whereas for the pin selection 0, the number of the pins you want to set starting from 0 to 15. That is why I said that whatever the number so you have which is greater than 15, you have to subtract from the 16 and then use the same logic. So I will copy the everything as it is. I'll copy everything. So I'll be using pin selection 1 because that is meant for the pin selection 1. So I will change to pin selection 1. This also will change to pin selection 1. So then what I'll do is, instead of whatever the pin number, 18 is the pin number. Yes or no? I'll take the 18 there. So I'll copy 18 there here for the pin. Only thing is I will subtract by 16 because it is greater than 15. That's all we have to do it for both pin selection 1 and 2. The remaining logic is same thing. Now what alternate function? Let's say I'll go to the last alternate function. So third alternate function, that is the last function. Among the 4 functions, the last function I'm going to choose it. So since I'm going to choose third one, I'll replace here instead of 2, I'll write 3, 0x03. So this is all my program. So I'll compile the program. So 0 errors. I'll go to the debug. Now, so first pin 5 is there. I'll finish those execution because I'm interested in the second one. Now, before I start this one, I set to the P0.18 because I want to observe that pin P0.18. So you can see that P0.18 by default on reset, it is configured as a 0th function, that is as a GPIO port pin it's used. So now what is the other alternate functions? So the first alternate is timer logic, second is SPA logic, third is a timer 1 logic again as a match 1.3. Now I want to set for the third alternate function. So for that I'm executing these two instructions. I'll finish execution of those two instructions. Now I finished. Now see that it is automatically 0.18 pin now act as the pin related to the timer 1 logic hardware, the peripheral. So the name of that pin now becomes what? Match 1.3. The name earlier was GPIO port 0.17. Now the pin name itself has changed. What is now the pin name? It's a match 1.3 pin name. That means that the name of the pin can be any one of the four. That depends upon what logic you set for that pin. So the same pin can act as what? The four different roles it can play, each pin. Now what is the role it's playing? The fourth role it's playing. So that means that this pin is being controlled by the timer hardware or the timer peripheral or the timer block present inside the microcontroller. So this completes understanding about the pin selection register for the microcontroller LPC2148. Now we will start writing programs for the GPIO block now. So let's understand now. We're taking a simple example. So I'm going to now, let's say, interface a particular pin. So of the microcontroller. So what is that pin I'm going to control now? Let's say there are 45 GPIO pins are available. In that pin, I'm going to control one pin. Now, to control that pin, I have to decide whether the pin I am going to use is an input or output. So this, I'll share it. I'm just doing something else. Yeah. So I was sharing to show you something else. That's what. Okay. Okay. So I was telling you that I want to now control the pins of the block. Now, let's say this is LPC2148. So now I know that there are 45 pins are there for this. And these 45 pins are distributed among the two ports. So the one port is the port 0. Port 0 I have. So other is port 1 I have it. So you can see that this is a less number of pins and this is a more number of pins you have. So in this one, you should know that I have P0.0 to P0.31 as available. Of course, 3 pins, as I've indicated when I explained the port, are not used. So only 29 are there in this one, except the 3 pins. All the pins are available there. So here, what are the pins available for me? P1.16 to P1.31 is available here. So these are the 16 pins, another 29 pins here. Now, I want to, let's say, use one of these pins to perform interfacing to the external devices. So whenever we want to perform interfacing to external devices, what are the things you should be able to take care? You know how to build a project. Let's say I am connecting a simple experiment to start with. I want to interface an LED to a microcontroller. What is the first thing you have to do? It first, make sure that give the power to the LPC2148. So we know that whenever we want to give a power to the LPC2148, so how many lines are required? I said there are pins available, 2 pins available. So one is called as the VDD, that is a power supply, that is a positive power supply. Other is a ground. So now what I'll do is I will select these 2 pins in the microcontroller. So the name of the first pin is VDD. The second pin is VSS. So what is the voltage I'm going to connect here? So I am take a adapter, purchase an adapter for 3.3 volts, and then I'll connect here. If I don't have an adapter for 3.2 volts, what we do, we purchase a 5 volts adapter. We use a voltage regulator IC. It's available in the market. That boards are available. So you can set to the whatever the voltage you require and supply the 3.3 volts to the microcontroller. So I'm just telling you the way you have to build your own boards. So fundamentals, it's very strong. If you are very strong in fundamentals, I'll tell you, any product you can develop using any microcontroller on your own. So with this intention, I'm going very slowly from the fundamentals of hardware and software both. So what is a VSS pin? So it's a ground. It's a CMOS technology. When you use the word D, drain, S means substrate. That means that they use a CMOS technology to manufacture this silicon chip. So now I given the power supply. Power supply is ready. Then just giving the power to a microcontroller is not sufficient. Generally, microcontroller requires 2 types of food is required for a microcontroller. Any microcontroller. So 2 types of food is required. So what are the foods? So one is the power supply food you have given it now. Now it's get heated up. All the logics are ready to work. But you have to drive the different logics. How do you drive? I said clock is the second life. It's like a heartbeat. So it's like a heartbeat. So giving the power is, that means that body is ready. But to make it work, you have to just push the microcontroller to start execute the instruction one by one. You have to give a clock. So what are the lines? As I said, we already studied. There are 2 pins are available for the microcontroller. So where you can connect what is called as the crystal. You can connect a crystal. So the names of those 2 pins are crystal 1 and the crystal 2. So the names of the pin is crystal 1. So other name is crystal 2. So these are the 2 pins which are available to a microcontroller. Now you provided it. Now what you should do it? You have to purchase a crystal. So how does a crystal looks? So crystal logically represented in the diagrams like this. So they will be written like this. So and then so we will write the symbol like this. Okay. So this is the crystal symbol. So I will take this crystal. I'll take this crystal. So I have purchased the crystal. So what is the crystal value I have purchased? By default for the LPC2148, everyone uses 12 megahertz. That not necessarily you have to use 12 megahertz. Yes or no? So generally most of the boards they use that one. So now what I'll do is I'll take this one. So connect this crystal. So the crystal 1 point, one connection will make it. I'll take another point. So I will connect to the crystal point. So this is how we do the crystal. So this crystal value, whatever I selected, is 12 megahertz, because when you purchase the market, you should ask for that. What is the frequency you required? So 12 megahertz. I've connected it. So generally, to reduce the noise, we use one capacitor, ceramic capacitor, across this point and across the other point. That is, at the 2 ends of the crystal, we connect one capacitor to the ground. So around 22 picofarads, depends upon the manufacturer's user manual you can refer. They specify what is the capacitor value you're supposed to connect here. Let's say 22 picofarads, I'll connect one here and one here. So why we do like that? To reduce the noise at this position, at this circuit position. So now, so I have given the power. So I given the frequency. Now, so this crystal uses the PLL logic and generates CC clock, that is CPU clock, which is of 60 megahertz. That has been further been fed to the BPB, the bus or APB bus. So and all the peripherals by dividing by 4. So 15 megahertz is a clock which is available inside the chip now. So you should always remember that. So whenever you write the logic, always, so this is the default values available unless you change the values. So since I'm using a PLL logic, this one, and the P clock is 15 megahertz. So this has been generated. So from the crystal. So now it's ready. Now whole thing is ready. Now I have to build my first project. So what is my first project? I'm going to connect an LED. So I will take an LED. I'll take an LED. So let's say I'll take one LED. So I'll take one LED. So okay, so now I have purchased one LED. So now I want to connect it. So among these, which line you're going to take? It is always left to you. You can take any line you are interested. So nobody stops you that you have to take only particular LED. So let's say I've taken P0.31, it's the last one. So what to do? Take that pin whichever there and connect that pin to here. So whenever you want to connect, shall I connect it here? Shall I connect here? It's all depends upon the common anode or common cathode logic. Let's say I follow the common cathode logic. So when I say common cathode logic, that means that what I'll do is I'll take this pin. So I'll take this pin. So connect to the cathode. Yes or no? The point, the anode point, which is a common point, I'll connect to the power supply. Since always you should be make sure that since the whole thing work at 3.3 volts, so I will connect this to the 3.3 volts. So I will take 3.3 volts supply what is available here. So I'll just connect to this point here, 3.3 volts. Only thing is I use a resistor in between. You can always use a small 330 ohm resistor. So whenever you require, so in between you can introduce one resistor. So in between you can introduce one resistor. Okay. So now I've introduced a resistor also. My logic is ready. So this is how you start building the boards whenever you got a microcontroller with you. Only thing is there is a pin called reset is available. That also you have to be handled. That I'll discuss probably in the next problem statement. In the next class I'll discuss. Because if you don't control the reset pin properly, it will not work properly. So reset is an hardware pin provided the microcontroller to provide two types of reset: power on reset. So and also the manual user reset. That is a product. Whenever you want to reset, you can provide a key through that you can reset the system. So that I'll discuss. So now let's start write the program. This is the hardware connection I made on the board. Now I have to write a program, convert into a file which is suitable for this, and I have to download into this hardware. What all the things required for that, we will learn that one. Now we'll start writing a program for this. Now, so when I want to start writing a program for this, you should understand what are the registers are available for programming these ports. So as we already studied, so three types of registers are available to program so the microcontroller. So what are those registers? So these are the registers which are available to program the microcontroller. So one is the direction register, then the set register, then the clear register. I will use the pin later because I am just controlling the output. Now, so we will understand what is the meaning of each of these register. So what is an IO direction register? So IO direction register is basically 32-bit register. So that means that, so if I let's say assume a register is like 32-bit. So if the first bit is, so P, the first bit is, let's say D0 is the first bit, D0 is the first bit. So, and the last bit is D31. Now, what is I have to do is, I have to use this register to configure the direction of the pin. So now which is a pin I've used? P0.31, I've used it. This pin, I can make it to act as an output or input. Now, what is the name of this register? The name of the register is, so IO0 dir. This name is being defined in the Lpc2148.h file already. Either I can write IO0 direction, or the compiler also supports IO direction 0. Both is possible. You can use any one of the name for that. Now, how many such registers are there? There are two registers are there. So one is IO0 direction, and then it is what? IO1 direction. So why two registers are there? Because so there are two such registers are there. One register for what? For programming the direction of port 0 bits. IO1 direction is another register which is used to program the direction of these bits. Now, how many bits are there? 31 bits are there. Now, how many pins are there? 31 pins are there. So that means that 1 bit of a register is required to control the direction of every pin. That means that, let's say I want to control P0.0. So which is a bit used? The first bit. So what I can write? If I write 0 here, that means that this pin, that is P0.0, becomes act as an input pin. It acts as an input pin. So you should decide whether I am using this pin as an input or not. Instead of 0, if I write here 1, then this pin acts as an output. That means that you can use this pin to drive the logic from the microcontroller to the outside world. So remember that 0 means input, 1 means output. So 1 bit in the direction register controls what? 1 pin here. Now, how many pins are there? 32 pins are available. So 32 bits are available here. For example, the last one. So I'm using P0.31 in my program. So P0.31 I'm using to control the LED. So which bit I'm interested? I'm interested in the last bit, that is D31 is the bit I'm interested. I'm using P0.31 to control the LED. So LED is an input device or output device? LED is an output device. That means that I'm using the LED. So I'm using the LED as an output device so that I want to send the data to LED. So what should I do? As I've explained, I write what? 1 year. So I'll write 1 year. So only when I write 1 into the direction bit, then only I can start using, because if you don't write it, by default it can be input. That is all would have been 0. That means that my logic, my program work. Most of the time projects will not work. Your programs will not work in the lab when we give an hardware board. What was a mistake? Usually people do it, as I observed, most of the students fail in the exam. They will not get the result only because they have not configured the direction register. If you don't configure the direction register, pins cannot be used as an output. It will not work properly. Even the whole program is correct, but pins will not behave as expected. So that is why always remember that. So you have to configure the direction of the pins before you start programming. So now I'll go back to the program now. So now I'll start the first instruction. So what is my assumption? What is my program and my problem statement? So my problem statement is, what? Interface an LED to P0.31 and write a program to toggle or to make it on and off. That is my program statement. So what is the first step required? So first step required is what? Set the direction of the pin required, So in this case, it is P0.31. So which is the register I have to take? IO 0 direction or IO 1 direction? Since I'm using P0.31 that belong to the port 0, so I have to use capital. It should be very important that, so it should be case sensitive, and they have all the names have been defined in Lpc2148 as uppercase. So you have to use uppercase only. IO, it is not O, it is 0 direction. So the moment I type this one, IO 0 direction, it is ready. So, or I can type as what? IO direction 0 also. I can select it as IO direction 0 also, I can select it. So now anyone I can use it. Let's say IO 0 direction, I use it now into. Now what should I do it now? I have to now set only the 1 pin. So there are 32 pins are available. Let's say no, 32 pins available. Last bit I have to make it 0. All the remaining pins up to 0th bit I have to make it 0. So this is equivalent in the hexadecimal as what? So 0 X. So the last is a 100. So 100 means what? It is nothing but this digit is becomes what? 8. So 8. So then 000 0000. So that I have prepared the pattern what is required to be written into this one. So I have written this one. So look at this. This has been ready. Now once the direction is ready, I can write some data into that. To start with, what I'll do, I'll just make the bit is equal to 0 or 1 like that. I'll test it whether it works or not. Then I'll write a program to make it toggle. So now, going back to here. So now I have understood direction register. Now I have to make it 1. There are 2 registers are available, which is called IO set and IO clear. These registers are used to make the pin 1 or 0. So why they have given the 2 and how I have to use it. So let's understand that one. Okay, I have taken now a register. So the name of the register is, let's say, set register now. So let's say this register is called, so IO0 set register. Now, how many such registers are there? 2 such registers are there. IO1 set. So the first register IO0 set is used to set or make any one of the port 0 bits one of the port 0. IO1 set is a register is used to make or set any one of the bits of the port 1. Even though there are 16 are there, but all registers of size only 32 bit, they are provided 32 bit. But in that only 16 bits are used because you have only 16 pins are available here. Now, so this is IO0 set is a 32 bit register. Now, how many bits are required to set a particular pin 1? So if I'm interested to make a particular bit, let's say P0.0, so I want to make it 1. So then I want to make this bit is equal to 1. That means that how many bits are required? It's only 1 bit is sufficient. So 1 bit can control 1 pin. So that 32 bits are there. 32 bit controls 32 pins. How do you control this one? So now let's say assume that I am taking into IO0 set register, so which controls the port 0. Now let us assume D0 now. So each bit corresponding to the corresponding pin. For example, 0th bit corresponds to what? 0th pin. The first bit corresponds to what? First pin. Similarly, 31st bit corresponds to what? 31 pin or port pin of the port 0. So that is a mapping directly is provided. Numbers are mapped directly to the corresponding bits to the pins. Now, writing 1 into the set register makes that particular pin is equal to 1. So this is the logic. So what is the logic? So whichever pin you want to make it 1, what you have to do? The corresponding bit in the set register, you have to write 1. For example, I want to make the P0.31 1. So what should I do? I'll go to the corresponding bit, then I'll write 1 into that one. So as the name says, set register can only make the pin 1. That's all. So it do not have the capability to make the pin is equal to 0. That means that, let's say I have now the D1 bit is there. If I write 0 into this one, does it make the P0.1 0? No. Writing 0 into this register have no effect. Writing 0 into this register have no effect. Only what is an effect? Writing 1 into any of the bit is have an effect. That's all. So set register is a 32-bit register. Writing 1 into any one of the bits will corresponding pin will make it 1. That's all. Writing 0 will have no effect. The beauty of the set register is that whichever the bit you set is equal to 1, only that bit becomes 1 and the remaining bits will not be affected. That is the beauty of this. See, whenever you are using the port for controlling the different logics, different pins are used to control the different devices, LED, LCD, keyboard, so many things are there. When you want to write into a particular pin, you should not affect the other pins data, because other pins data you would have sent earlier in the program to realize certain logics. The moment you write into the P0.31, let's say set register is not there, assume that. You can directly write into the port 0. Port 0 is equal to something. Then what will happen? In the process of writing to some other bit, you may disturb the some other bit. That is why they provided a concept called set and clear register. So that when you use a set register, whichever the bit you set, only that bit becomes that pin it controls. Remaining bits will not change. That is why they have used it. Now come back to the programming. Having understood this one, now I will set the P0.31 as 1. So IO0 set, so equals, let's say 1. I want to set that 1. We know that. So setting 1 in the last bit is nothing but what? The same thing, 8000000. Because why? I want to set, so the P0.31. So P0.31 is nothing but what? The last bit. So I want to set only that pin. So I'll make it 1, remaining 00. So I've written this value. Now I'll stop my program here. I'll debug and see that whether that bit is set after I execute that instruction. So there are some errors are there. So I think I have not made comment. So, and also I'll write one more instruction to clear that bit so that we can see both at a time. So IO. So similarly, setting a bit, that is making a bit is equal to 1, a pin is equal to 1 is controlled by set. The opposite of logic is clear. Any bit in this register, you make it 1, the corresponding pin becomes 0. That means that to make it 0, you have to use this register. So I will use the same bit. So what I'm doing now, I am making a particular bit on and I am making a particular bit off. So let's compile this program. Now let's run this program now. Now I will drag the peripheral. So because I want to see that whether it's working or not. So I'll take this, I'll drag. GPO, there are two types of interface there. One is slow interface, fast interface. Fast interface will not use in all of the syllabus in this course. If you want to drive the port signals in a little faster speed, you can use a faster interface. This is connected to a local bus, so you can always use this one. So whereas slow interface is connected to VPB bus, so I'm using this one. So see that when I pull this block, that is GPO block, all the registers related to that block comes into picture. When I pull the pin control block, then what will happen? All the registers related to what? That block comes into picture. So when I pull some other, let's say I2C interface, all the register connected to that, it will come. So that means that a microcontroller will have number of programmable registers present in the core, present in the outside the core, in the different box. So as a programmer, the challenge is what? You should understand the different registers generally provided in each of the blocks, and you should be able to program them. That is what systems programming is. So, or embedded systems programming is. So generally, if you know one microcontroller, the way you program one microcontroller will always help you to understand any other microcontroller, because the names of the register may be different, the number of registers may be different, but the method will be similar. So that is why, so understanding one microcontroller, so generally be helpful in further in your studies, or when you get some projects, or when you go for higher studies. So recently, one student, I think Ramya, she was a ranked student, she passed out 2 years back. So she mailed me saying that whatever she studied, I would like to share that. So it is sometimes some of the things. So it will give inspiration for you. So she was a topper actually. She was a guy to first rank, third, and I don't know. See, sir, she has written. This is Ramya Ranathan from the 2015 to 19 CS batch from RVC. I hope you're doing well and that your family is safe. I've just started first semester of my master's, and we had a project on x86 assembly language this week. I was reminded of your early morning classes. You used to explain the concepts. Okay, a lot about what you taught us, even though it has been 3 years. So this is how I wanted to tell you that. That means that you may feel that sometimes why this subject is required, why I should know, go into the details. Already I can use Arduino board, I can use RPi board. It's not like that. These fundamentals will always helpful for the longer time, and whenever you are going to work on different systems projects or networking companies, or when you do your masters, even though we say that it's a old 8086 processor, even now it has been used as one of the subjects in the masters in so many universities abroad. Because assembly language enables us, the embedded C program enables to understand the hardware in a better way. So that is why I strongly recommend generally. So make sure that the concepts drives you. So once you know the concept, always given any microcontroller, any board, it's just a question of 1 or 2 days, because you are very good in concepts. So for example, if you know GPO programming of one microcontroller, I'll tell you any GPO programming of any microcontroller or processor, you can manage, because the concept will remain same thing. So coming back to here, so I was telling that these are the registers which forms the GPO block. IO direction, we have understood now. So what is the meaning of a direction register? So among these bits, you have to make it 1, whichever the bit you're using as an output to set the direction. Now, IO set register is used to make the corresponding bits, you have to make it 1 to make the pin is equal to 1. So IO clear, you have to make this any one of the bits of this register 1 to make the pin 0. So this is IO pin register. So this we will see that how you can use this register to read the data on the pins. Now these are the physical pins of the chip. So what do you mean by physical pins? So that means that these are the pins, physical pins. That means if you take a multimeter or oscilloscope, if you just check at this point, whatever the data you get, this and this both will be the same thing. So only thing in oscilloscope you get what? 3.3 volts in a multimeter oscilloscope. Here you can see that tick. Tick means it's a 1, 3.3 volts. No tick means it's 0, 3.0 volts. Otherwise it will be exactly same thing. So I will show you also how you can use an oscilloscope which has been provided in the kill simulator to check the voltage value at this point. Now, so now I will execute each of the instruction. See that what happens here. Now I'll execute the first instruction, IO direction. See that bit becomes 1. The moment you made the bit is equal to 1, see the pin, it has been open now. It's open in the sense what? 0. So by default, so whenever you configure the pin as output, the value becomes what? 0 voltage there. 0 voltage there. So now if you go and check in the multimeter at the pin P0.31, you get a 0 voltage because there's nothing is there here now. So now you can control at the pin the voltage based on the set and clear register. Now I'll execute the set register. Since I've written 800, that is the last bit, so it will write into this position. See, I'll write. So see, the moment you write into this 1, what will happen? The pin also gets 1. So that means that if you take in a multimeter and observe that 3.3 volts, you can see at this point now. Now again, I'll make it what? So execute that instruction. See that? So it has become 0 now because what? So you return into the clear register 1. It is not indicated here, but it is automatically becomes what? It will become a 0 here. So writing into this register, so automatically it is made into 0 here. So this is how you can control any one bit of the microcontroller here. So now, so I will stop this program here. So otherwise I'll reset. So I will go to the again run. So am I audible now?
Yes, sir.
Yeah.
Yes, sir.
Yeah, I'll share and come back. Okay. So now we will write making 1 or 2 bits, different bits on and off, and we will see that. Okay. So now I want to make, I'll change the program, let's say bit 0 also to make it on and off. So what I'll do is, so I want to make the bit 0 also 1. So I want to make P0.0 and P0.1 also on. So I just change 1 or 2 things. Okay. So what I'm making now, P0.0, I'm making it 1. I want to bring the changes on that pin so that I will change the direction to 1. And also P0.2. So what is I'm going to do it? I'm set the direction of the pin required. Which are the pins I'm setting? P0.31, P0.0, and P0.2. So these are the things I'm going to change it for just for experimenting it. So now, so since the different bits you're using, this becomes what? Is a 4, 1 plus 1, 5. It's become 5. So now what I want to do, I will also make these pins also 1 in the program. So what I have to write here, so because I'm writing the 1 there, I'll write 1 here. So then I want to make it 0, I will make it 0. So what I'll do, I'll put this in a loop just to see that whether the bits are getting on and off or not. So I'll say while of 1, or anyway, it's already while is there. So I'll just say do while 1. Okay. So now what I'll do is, so I'll make, which are the pins? P0.0, P0.2, P0.31. Those bits I'm making it 1 and then 0, one after the other. So to just see that how the direction and set and clear register I can use to set different pins on and off. So it's just as an example. So now I'll execute the instruction. First instruction I'll execute. Oh, sorry, I have not changed in the so I'll change here also because I have to control. So if I don't write this one, you can experiment it. If I don't set the corresponding direction register, it will not change here. So it's very essential. The bits you want to control using a set and clear register, you have to make them as 1 in the direction register to use them as an output pins. So now I'll execute this program now step by step. So see that the corresponding bits 0.0, then 0.2, port 0.0, port 0.2, and port 0.31. I'm used it. I want to make it on and off. See that? So I'm making it 1. So I'm making it so clear. Again, I'm making it 1. So set. So clear. So it becomes 0. If I run it continuously, so you can see that those bits which you are interested, look at that, 0.0, 0.2, and 0.31. So I'm making it on and off. That means that, so whatever the device you connected these pins will also get this logics, you'll be getting it. So now, so to see that this, whether how his signal is coming, I want to observe that signal. There is one tool called analyzer, is a logic analyzer. Either you can choose from these shortcuts or you can go to the view. So there also analysis windows also, from here also you can take it from anywhere. So I'll take a logic analyzer. So now already I've set it for certain things. I'll clear everything. I'll go to the setup. I'll go to the setup. So I'll kill all. I removed all the signals. Let's say how to use a logic analyzer. Whichever the pin you want to observe, that you have to add to the logic analyzer. The logic analyzer means it is nothing but you are connecting this tool to the particular pin here. For example, I want to observe this pin here in the oscilloscope. So you say this is a new is there here. Click on the new, type that pin, whatever there. You have to type in the capitals only, proper, P-O-R-T, like that only you type it. So which is a signal I want to observe? Let's say port 0.0 I want to observe. Just say enter. The moment you say enter, again select that signal, you can see that this is AND combination. Yes or no? Will exactly give you 1 bit. So you're taking 32 bit of the port 0, ANDing with 0001. When I AND it with 00, what will happen? All the bits become 0. Only the last bit remains. That means that this combination refers to what? Only 1 bit of the complete port. So using this, you can able to monitor what? 4 bits. So 5 bits or the whole port you can monitor. So that is what this combination given. So whatever the combination is given here, you can see here. So what is the AND mask and what is the shift right? If you want to observe the second bit, let's say I will go into add before adding another pin. Set the color of this signal. So you can make it red or whatever the color. Let's say I want to make it so green color. You can make the color of the signal in the oscilloscope. And what is the nature of the bit? Is this bit generates analog voltage or it generates a digital voltage? We know that GPIO, what is the behavior of the GPIO pin? Each of the port pins of the GPIO are digital pins. You should always remember that because each pin can take only two values, either 1 or 0, 3.3 volts or 0. That is why it's always what? It's a digital in nature. Since the pin is a digital in nature, I'll make it a bit. So it's a bit. So that means that minimum is 0 always, the maximum is 3.3 volts. Bit means 0 or 1. Now, so I will finish this one. I'll just check for one pin. I'll say, now I'll set go to this one. You can see here. This is the pin what you are referring now, the 0.0 pin. Yes or no? The signal is coming. You can zoom this one. You can zoom. See, you can see that. So the waveform is generating. That means that the pin, whatever you are generating, see that waveform is moving as it's some. So like this, you can able to use this logic analyzer. Yes or no? So whenever you want to observe this one, so you can just stop this logic analyzer. You can use the timing signal. You can keep the timing signal here. How much is the time required from here to here? You can measure all those things is possible. So many things you can able to do with the logic analyzer. So I request you to go through some of the videos and such, and how you can able to use the measurement scales and other things you can able to do it. So I can just continue instead of start again, update the screen. So like this, I can able to observe what are the different pins, what is happening, whether your program is working or not. So tomorrow when you download this program, it works in a similar fashion. So now I'll stop my program. So I've seen that how I can use a logic analyzer and how I can use the peripheral to observe what is happening in the program. So now what we'll do is we will make one pin only, that is a P0.31 pin, make it on and off and make the LED blink. Now it will blink, but it is so fast because it's executing at what speed? 60 megahertz. So the clock speed, that is C clock. So you cannot observe anything. You have to introduce certain delays in the program. Then only you can able to observe. So let's write on delay program. I've already written that. I'll just copy the delay program here. So you can always write a for loop after the set and write one more for loop after the clear. You can do like that, or you can call the delay program. I written on delay program. So delay MS I given for the kit what we have in our college laboratory, that is Lpc2148 kit, developed by R&D team of the CS lab. Your senior students have worked on it. We have developed our own board, which is the first of its kind in the country. Even IITs, they do not have their own design board. So we have designed our own big board, which you can conduct around 30 experiments, starting from normal sensor integration to the IoT experiments. So we have developed last year with the help of the senior students. So 2-3 revisions we made. The board is beautifully, it's working, it's available in the lab. So probably this time I do not know whether we can conduct a lab for this. So that's why we are teaching you through simulator. But see that, let's see, if possible, we can have 1 or 2 sessions in the lab. We will see that. So that board, so we have designed in that board, this 10,000 value, if I run it, it was producing a delay of 1 millisecond. See, always, whenever you write the delay millisecond program, it is like at the low level operating system. In operating system, you get a ticks, tick 1, 2, 3, like the ticks, you are getting it. Based on that only, you define so many functions in the operating system. Based on that only, you can do the scheduling. You divide the task, you give the time for the tasks. All those things is basically the tick sound in the operating system. Basic ticks. So now, how do they produce the basic ticks? Because the operating system is nothing but what? A software running on a microcontroller. Yes or no? So the basic ticks will be produced as program like this ticks, and they would have tested for a particular hardware, for a particular microcontroller, how to produce a particular millisecond. It's a trial and error. So we did a trial and error for in our board. So for this value, approximately we were getting 1 millisecond. So for a PLL enabled, if you get a PLL enabled, we were doing this one approximately, we were getting it. So 10,000, we getting. You can use the different values, you can test it. So once it is decided, so you're getting a of 1 millisecond for this power loop, you can keep this as a standard for all your projects. So this will be the base tick sound for your projects. Now I'll call this delay program. So whenever we write a function, always make sure that in the key, you give a prototype definition. So you define this function, give a prototype declaration. So copy that and just say semicolon. So the prototype declaration is a must whenever you write a function below the main. So in the key. So I just given the prototype declaration. So then I'll call this program. I'll call this function, Control C. So I'll invoke this function with a value of, let's say, 10 millisecond. So then again, it's very important that, so after becoming 1, you are producing delay. That means that the signal stays at the high for 10 millisecond. If you want to make the signal is low and then also stay for 10 millisecond, you have to put here again the same thing. So control P. So this is one of the quiz question we asked. Write a program to generate a square waveform on a particular pin. This is one of the quiz question on exam question. So this is all the program. So what I've written, the program is what? It produces so square waveform on the pin P0.31. So now I'll compile my program and see that all the logics are working. Okay, so there is no errors there. So no errors there. Now I'll go to the debug. Now I have an oscilloscope also. So I'll keep an oscilloscope here. So now I'll start executing it. Whenever you do in a single step execution, so you should be very careful that, see, IO set is okay. After that, when you come to the delay, don't execute. You have to step over that. You should don't get into this one function. Yes or no? In a single shot, you have to finish that. So there are 2-3 options for this: step out, step in, and step over. So I'll say delay. I finished that. So then again, so clear, then so finish that and continue. So this is there for do while and then it continues. So come back. So I'll run continuously. So now see that this point is changing. So I'll just see that have I set up for that particular pin. So I'll go to the setup. See, it's not there. What is the pin? It is P0.0. So now what I'm not interested in this pin. What you can do is you can delete that particular pin. You can add one more. So port 0.31. So I'll enter that. So I'll select that. So make the, so okay, select the bit as the bit. So then I'll say